In this video, we will discuss solving quadratic expressions by factoring. The zero product rule. If A times B equals 0, then A equals 0 or B equals 0, or both, where A and B are real numbers. To solve an incomplete quadratic equation, ax squared plus bx equals 0, by factoring, use the addition axiom to write the equation in standard form. Factor out all common factors and set each factor containing a variable equal to 0 using the zero product property. Solve for the variable in each equation formed in step 2. Then check each equation in each solution in the original equation. For example, solve 2x squared equals 5x for x. First, we write the equation in standard form by subtracting 5x from both sides. 2x squared minus 5x equals 0. Now we factor out x from each term and rewrite the equation as x times 2x minus 5 equals 0. Then we can separate this into two linear equations, x equals 0 and 2x minus 5 equals 0. X equals 0 is already solved for x. If 2x minus 5 equals 0, then 2x equals 5 and x equals 5 halves or 2.5. Now we check both solutions to make sure they work in the original equation. If x equals 0, then 2 times 0 squared equals 5 times 0. Thus, 0 equals 0. This solution checks. If x equals 2.5, then 2 times 2.5 squared equals 5 times 2.5. That's 2 times 6.25 equals 12.5. So 12.5 equals 12.5. The solution checks. Solve 4x squared minus 8x equals 0 for x. The equation is already in standard form, so we start by factoring x from each term and rewriting the equation x times 4x minus 8 equals 0. We further separate the equation into linear equations x equals 0 and 4x minus 8 equals 0. X equals 0 is already solved for x. If 4x minus 8 equals 0, then 4x equals 8, so x equals 2. Check both solutions to make sure they work in the original equation. If x equals 0, 4 times 0 squared minus 8 times 0 equals 0. That is 4 times 0 minus 0 equals 0. 0 minus 0 equals 0. The solution checks. If x equals 2, 4 times 2 squared minus 8 times 2 equals 0. 4 times 4 minus 16 equals 0. 16 minus 16 equals 0. The solution checks. Factoring general quadratic expressions. There are two standard methods for factoring general quadratic expressions, trial and error and the easy way. I'm going to stick to the easy way. Trial and error can require examining up to 8 equations, and generally it's a pain in the posterior. Here's my easy way. First, write the expression in standard form, ax squared plus bx plus c. Then multiply a times c. Find two numbers that multiply to ac and add to b. We will call these m and n. Then rewrite the original expression as ax squared plus mx plus nx plus c. Factor ax squared plus mx and nx plus c. You should find they have a common binomial factor. Add the remaining factor of ax squared plus mx and the remaining factor of nx plus c to get the remaining binomial factor of the expression. Write the original expression as a product of the binomial factors found in steps 5 and 6. For example, factor x squared plus 4x minus 12 the easy way. The expression is already in standard form. Here a equals 1 and c equals negative 12. So ac equals negative 12. We want two numbers that multiply to negative 12 and add to 4. We can find these numbers by looking at factors of negative 12. Negative 1 plus 12 equals 11. Negative 2 plus 6 equals 4. The numbers we want are negative 2 and 6. Rewrite the original equation as x squared minus 2x plus 6x minus 12. We factor the first two terms together and the last two terms together. X squared minus 2x equals x times x minus 2. And 6x minus 12 equals 6 times x minus 2. Each pair of terms has the common binomial factor x minus 2. The remaining binomial factor will take the sum of the x from x times x minus 2 and the 6 from 6 times x minus 2. So it is x plus 6. So x squared plus 4x minus 12 equals x minus 2 times x plus 6, and we confirm this by multiplying. We FOIL out x minus 2 times x plus 6 to get x squared, that's x times x, plus 6x, which is 6 times x, minus 2x, which is negative 2 times x, minus 12, which is negative 2 times 6. And when we combine those terms, we get x squared plus 4x minus 12. Factor 20x squared minus 23x plus 6 the easy way. A equals 20 and C equals 6. So AC equals 120. Look for numbers that multiply to 120 and add to negative 23. They must both be negative since the sum is negative, but the product is positive. There are a bunch of possibilities, but we'll ultimately find that the numbers we want are negative 8 and negative 15. Rewrite the original equation as 20x squared minus 8x minus 15x plus 6, and factor 20x squared minus 8x to get 4x times 5x minus 2, and factor negative 15x plus 6 to get negative 3 times 5x minus 2. The common binomial factor is 5x minus 2, and the remaining binomial factor is 4x minus 3. So 20x squared minus 23x plus 6 equals 5x minus 2 times 4x minus 3. We multiply to confirm. 20x squared minus 15x minus 8x plus 6. We get the 20x squared from 5x times 4x. The negative 15x from 5x times negative 3. The negative 8x from negative 2 times 4x. And the 6 from negative 2 times negative 3. Add it all up, we have 20x squared minus 23x plus 6. It's important to recognize that not all quadratic equations can be factored. Consider the expression x squared minus 3x plus 6. This is a pretty simple quadratic expression, but if we look for two numbers that multiply to 6 and add to negative 3, we will not find whole number answers that work, which means we won't find rational answers that work either. In fact, while there are solutions to this equation, they are complex numbers. In short, sometimes you just can't factor a quadratic expression. There are a couple of patterns you may see that can clue you into quicker factoring. A difference of squares means that we are looking at the product of conjugate terms. If you see ax squared minus c, where a equals m squared and c equals n squared for real numbers m and n, then ax squared minus c equals mx plus n times mx minus n. A perfect square trinomial has the form m squared x squared plus or minus 2mnx plus n squared. That is, in this case, a equals m squared, b equals 2mn, and c equals n squared. If you run into this pattern, ax squared plus or minus bx plus c equals mx plus or minus n quantity squared. Remember that 1 is a square number, so if there is no visible value of a and no negative sign in front of the quadratic term, you can still use these patterns. For example, factor 16x squared minus 9. Here a equals 16, which is 4 squared, and c equals 9, which is 3 squared. Since a and c are both square numbers and there is no linear term, 16x squared minus 9 equals 4x plus 3 times 4x minus 3. Factor x squared minus 8x plus 16. Since a equals 1 and c equals 16 equals 4 squared, we check to see, does b equal 2 times 1 times 4? It does. Since this is the case, this is a perfect square trinomial, and we can quickly factor it as x squared minus 8x plus 16 equals x minus 4 squared. Note that since b equals negative 8, we use negative 4 instead of positive 4. The square is the same either way. That is, the square of negative 4 is equal to the square of positive 4, not the square of x minus 4 squared is equal to the square of x plus 4 squared. Now that we can factor general quadratic equations, we can solve complete quadratic equations by factoring. To solve a complete quadratic equation, ax squared plus bx plus c equals 0 by factoring, first arrange the equation in standard form. Second, factor the trinomial into the product of two binomials, and set each binomial factor equal to 0 using the zero product property. Third, solve for the variable in each equation formed in step 2, and fourth, check your answers. The book makes that last step check if desired. I say heck with desired. Check your answers. For example, solve x squared plus 6x plus 5 equals 0. Start by factoring the expression x squared plus 6x plus 5. Here a equals 1, c equals 5. So ac equals 5 and b equals 6. We're looking for two numbers that multiply to 5 and add to 6, and those numbers are 1 and 5. We can take a shortcut here since a equals 1 and factor this as x plus 1 times x plus 5 equals 0, and you can multiply to check if you want. Then, if x plus 1 equals 0, x equals negative 1, and if x plus 5 equals 0, x equals negative 5, and we check both of these solutions. If x equals negative 1 squared plus 6 times negative 1 plus 5 equals 0, 1 minus 6 plus 5 equals 0, 0 equals 0, the solution checks. If x equals negative 5 squared plus 6 times negative 5 plus 5 equals 0, that's 25 minus 30 plus 5 equals 0, 0 equals 0, the solution checks. Solve 6x squared plus 4 equals 11x. First, rewrite the equation as 6x squared plus 11x plus 4 equals 0. Now a equals 6, b equals negative 11, c equals 4, so ac equals 24. We want two numbers that multiply to 24 and add to negative 11. Those numbers are negative 3 and negative 8. Write the equation as 6x squared minus 3x minus 8x plus 4 equals 0 and factor as we saw before. 6x squared minus 3x equals 3x times 2x minus 1. Negative 8x plus 4 equals negative 4 times 2x minus 1. We wind up with a factored form of the equation 2x minus 1 times 3x minus 4 equals 0 and solve. If 2x minus 1 equals 0, x equals 1/2. If 3x minus 4 equals 0, x equals 4/3. And we check both of the solutions. If x equals 1/2, 6 times 1/2 squared plus 4 equals 11 times 1/2. That is 6 times 1/4 plus 4 equals 11 halves. That's 3 halves plus 4 equals 11 halves. 3 halves plus 8 halves equals 11 halves. The solution checks. If x equals 4/3, 6 times 4/3 squared equals 4 plus 11 times 4/3. 6 times 16/9 plus 4 equals 44/3. That's 32/3 plus 4 equals 44/3. 32/3 plus 12/3 equals 44/3. The solution checks.